In this lesson, we're going to look at all the types of transformations that we have learned so far and apply them to just one question. So to summarize the different types of transformations that we have done, the A is your vertical stretch or compression. The negative sign in front of the A is the reflection around or about the x-axis. The B inside the bracket, this is your horizontal stretch or compression, and the negative in front of that B is the reflection about the y-axis. The H will shift the graph left or right, so it's a horizontal shift, and then the K will shift your graph up or down, and that is your vertical shift. In example 1, we are given the graph of f of x, and we want to find the transform graph. What we're going to do is find our new transformation for each point. So I'm going to write my xy point in terms of my transformation. What's being affected by the x is this half here, and then this -1. For the half, if we want to write this in terms of how it's being affected on that x value, this is going to be not a half, but 2 times x. And instead of -1, we would add 1 because we're moving to the right. So this is kind of like a rule that you need to remember about transformations. For your x values, so kind of almost the opposite of what is being stated there when you are describing it out into coordinates. Then for your y, it's a bit easier, is exactly how you would read it. That's 2 times y, you have a vertical stretch of 2, and then we're going to go down 1, so 2y minus 1. Now I'm going to perform this transformation on all the points. I'm going to pick 3 points. We have this one here at 1, 2, 3, -4, -2. Another point at -2, 2. And then lastly at -1, 1. We're going to put it into our transformation point. So that's 2 times the x value, which is -4, plus 1, 2 times our y value, which is -2, minus 1. So that's going to be -8 plus 1, which is -7. 2 times -2 is -4, minus 1 is -5. So that is our new point. And do the same thing for our next point. Two times -2 is -4, plus 1 is -3. 2 times 2 is 4, minus 1 is 3. And then we're going to do this for one more point. 2 times -1 is -2. -2 plus 1 is -1. Then you have 2 minus 1, which is 1. These are the points we're going to graph. And we will have to extend our graph a bit because it goes off the grid. Okay, so we have a point at -7, -5. -3, 3. And -1, 1. Then we're going to connect our points from our most left point to our most right point. And that is our transform graph. If you want to find the domain and range of the new function, our most left x value is -7, and we include that. Our most right x value is at -1. Our most bottom point is at -5, and our highest point is at 3. And that's our domain and range of the new function. I'm also going to do a little bit extra work here. A lot of these questions in your provincial exam will ask you to describe the transformations. So we're going to describe these transformations then, and an order also matters. You must state that you multiply first. So you're going to state your vertical stretch or compression and your horizontal stretch and compression first, and then state the shifts up and down or left or right. Okay, so I'm going to describe this on the side here. We can say that there is a vertical stretch of 2, and that's coming from this one over here. Then we need to say that we have a horizontal stretch of 2. You would do 1 over 2 to find that. Then we can state this one. We went to the right 1. And lastly, this -1 here affects your y, we moved down 1. All right, next example. We are going to use the graph the root of x to graph our new transform graph. I'm going to rewrite this. So I'm solving for y, or in terms of y. So y is equal to 2 root. And I'm also going to factor out the negative, because if we looked at up here, that negative is factored out. So if I factor out the negative, I'm left with x minus 3. I'm going to move this plus 1 to the other side, so it's -1. So this is the graph we're going to draw. If we want to use our transformation method, we can do that. Our regular point xy is going to be changed to a reflection in the y-axis, and then we're going to move 3 to the right. For your y, we're going to multiply it by the 2, this is a vertical stretch, and then go down 1. Now, some points from our regular root x graph, if I want to quickly draw it, it looks something like this. That's what your regular y equals root x graph looks like. You have a point at 0, 0, at 1, 1, and at 4, 2. This is a graph you should probably have memorized as one of your basic graphs. Then we can apply the transformations on those points to find our points for the new graph. So we have 0 plus 3, which is 3, 2 times 0, which is 0, minus 1. That is your new starting point. So instead of 0, 0, you're going to start at 3, -1. Our next point is -1 plus 3, which is 2, and 2 times 1, which is 2, minus 1 is 1. Lastly, we have -4 plus 3, which is -1, and then 2 times 2 is 4, 4 minus 1 is 3. I'm going to graph these points. Okay, And then I'm going to connect them from my starting point, which is 3, -1. That's something like that. Now we want to find the domain and range of our transformed graph. Our domain is going to be our most left point, and we have an arrow there, so that's -infinity to our starting point, which is at 3, and we touch that as part of our graph. Our lowest point is at -1, and then we just go up from there because there's an arrowhead at the end. It goes on forever. In our next example, we want to work backwards. We were given the 2 graphs, and we want to find the equation for the transformation. So we know this green one here. This is y equals the absolute value of x. And it doesn't go on forever. It's just a portion of this graph. Now, if I want to find the equation of the image graph, I'm going to compare my vertex point, and this will give me my shift to the right and my shift up. So before we had a vertex point 0, 0, our new point is at 7, 2. It looks like we moved 7 to the right. And then we also moved up 2. So if I want this as an absolute value for now, this is going to be x minus 7 in the absolute value brackets. And then up 2 would be on the outside the absolute value brackets. So this is what we have so far. Of course, it's not a final answer because if you take a look at our picture here, they don't have the same stretch or compression. They're different. Is find the vertical stretch or compression. Now, you could use a variable, let's say a, to represent that for now. We do have points of this new graph, x, y, and we can pick either or, it doesn't matter. So we can use a point 8, 10, plug it into this function and solve for a, or you could also do that with 6, 10. It'll give you the same answer. So let's just pick 8, 10. So y would be 10 then. I'm solving for a, x is going to be 8. The absolute value of 8 minus 7 is just 1. And then I'll subtract 2 on both sides. So a is 8. Which means that we have our absolute value as y equals 8. Absolute value of x minus 7 plus 2. This is one possible solution. There are other ones. Instead, you could have found the horizontal stretch of compression by putting a value like b in there, and then doing the same process. You pick an x and y coordinate already on our transform graph. So for example, you could have picked 8, 10, plug it into your x and y and solve for b. And the difference is you would have gotten y equals absolute value of 8 times x minus 7, end of absolute value plus 2. This is another possible answer you could have had. And if you went really fancy dancy, you could also find another one which has a vertical stretch and a horizontal stretch. And this would have been another one that got you the same graph. So any of these 3 answers are acceptable. This last question I want you to try it yourself. There was a little typo in there, so go ahead and try to correct that. And then find out your transformation point. Find those new points, graph them. And then when you're done, press play. Okay, so for this try it yourself, I'm going to start off by finding my new transform point. For my x, I have a reflection in the x-axis. Then I'm going to multiply it by 2 because there's half in here. You're going to do 1 over 2, which is 2. And then we're going to go to the right by 1. Then for our y value, this is 1/2. And we have a reflection in the y-axis here. Then we're going to move up 3. So this is what your transformation is going to look like. We're going to pick the points that were given to us in this graph. So I'm going to pick these 4 points. We have one at 0, 0, another one at 2, 2, another one at 4, 2, another one at 6, 4. We're going to go ahead and find our new points. So we have -2 times 0, which is 0, plus 1. Then -1/2 times 0, which is 0, plus 3. So we have a point at 1, 3. Our next one, we have 2 times -2, which is -4, plus 1 is -3. Then we have -1/2 times 2, which is -1, plus 3 is +2. Our next point is 4, 2. So we have -2 times 4 is -8, plus 1 is -7. Then 2 times -1/2, which is -1. -1 plus 3 is 2. Lastly, -2 times 6 is -12, plus 1 is -11. 4 times -1/2 is -2, plus 3 is 1. These are our points, and yes, it's off the grid. We can just continue this grid so that we can graph our transform graph here. All right, so I'm going to graph our first point, which is at 1, 3. Then our next point is at -3, 2. -7, 2, and -11, 1. Now I'm going to connect our points in order. This is our transform graph. I want to find the domain and range. So the domain and range of the new function, the transform function, is from -11 to 1. Your range of your new function is from 1 to 3. And if you want to find the domain of your original function in range of f of x, your domain is from 0 to 6. Your range is from 0 to 4. So if you wanted to find, let's just say we weren't given this graph and you want to find the domain and range of your new function, we can do that by using our transformed points here, which is this yellow highlighted one, -2x plus 1. And if you want to find the range, you're going to use the green one, which is -1/2 y plus 3. So just on the side here, if you want to calculate your new domain and range, you can just take the transformed x and apply it to both bounds of your domain. So this would be -2 times 0 plus 1, -2 times 6 plus 1. Then your domain is going to be 1, -11. But of course the order matters, so you're going to switch this to -11 to 1, and that's how you got your new domain. If you want to find your range, same sort of thing, but for a range we're using this 1/2 y plus 3. And our y for our most bottom range is 0, our most top range, we're going to use 4. Okay, so then now we're left with 3. And the other one, we have -2 plus 3, which is 1. And again, the order matters, so we're going to switch this as 1 to 3. This is how you would find it algebraically if you didn't want to use your graph. Or let's just say you weren't given a graph, you can still do this algebraically if you find